So we have established that the particle arriving at the second photographic paper is travelling faster than the speed of light. This particle has come from the beam of light. Light is a massless particle, so this particle is coming from a massless particle. It is itself massless. If it had mass, it would not be able to travel faster than the speed of light. This is because of Einstein's mass infinity theory, where there is not sufficient energy in the entire universe to create mass traveling at the speed of light. It's not possible. So, like light itself, this particle arriving at the second photographic paper is a massless particle. It is also a nano-sized particle. It's very, very small. And it has a positive charge. That is why it is being picked up by the monitor. I was staying in the Walnut Inn in Mere the week of the coronation of the king. It was extremely wet. There were downpours of rain, heavy thunder and lightning, and the room I was staying in, the lightning tripped the switch on the circuit to my room, and that is what triggered this pattern of thought in my mind. What I have called this theory is the Walnut theory, after the pub's name, the Walnut Inn, because it suits the theory that every photon has a shell of what I call sertrons, this nano-sized, massless particle with a positive charge I name a sertron. And these are travelling at more than pi times the speed of light in order to circle each photon of light and create the shell. And this is what is going on. This is the first proof of the existence of a sertron. The second proof is the atom itself. I believe these sertrons also form the shell of every atom. At the center of every atom we have the nucleus and the protons positive charged, and the electrons going around that. And the element is decided by the number of these protons and electrons. So in hydrogen we have just one proton and one electron, all the way up to lead, which might have 82, I think, similar number of each. The higher up the scale, the more radioactive the substance, the element becomes, and the more unstable. Schrödinger described the situation in the atom because with the positive charge of the proton and the negative charge of the electron, we would expect the electron to collapse into the center of the atom. But that doesn't happen. An atom is surprisingly stable. Schrödinger suggests this is so because as the electron moves towards the proton, the energy divides into two forms, thermal and kinetic, and these forms have different wavelengths, and the different wavelengths cause a hopping effect as the electron approaches the proton. This is true, but it's not the reason why the atom is so stable. The reason is the sertron, the shell of the atom. The reason why the cirtron and the electron do not combine is because the electron has mass. It might be very, very small, but there is some mass, and therefore it cannot exceed the speed of light. The cirtron, however, is travelling at more than pi times the speed of light. It has to do so in order to circle around the atom or around the photon in order to remain. The electron, therefore, cannot combine with the cirtron because it simply can't keep up with it. And this also shows why an atom is so stable. Further proof then, if we go to a black hole, we know that when a star runs out of fuel, it turns into a supernova and then falls into a black hole as matter is drawn into the core of the fallen star. Now, what is going on? What is going on is the matter is going into the black hole so quickly that we cannot see it. It is going faster than the speed of light. So what is happening to the atom? It is traveling faster than the speed of light, so the cirtron can no longer retain the shell around the outside spherical circumference perimeter of the atom, and it cracks apart. The protons, the center, and the electrons are all consumed into the black hole, and the cirtron can escape. Around every black hole, there are these fields, force fields. These are fields of cirtrons, and that is the reason why they exist, these force fields around every black hole.